Welcome to this webinar on advanced use of Transkribus. My name is Annemieke Romein. I'm a postdoctoral researcher at the Huygens ING in Amsterdam. And I have worked for over 1.5 years, nearly 2 years with Transkribus now. And although I'm not affiliated in any kind of form with the program, I am an advanced user, and I'm using that knowledge to provide you insights as to how to work with the tool. You may have seen the basic webinar, which is also online, or you may have attended it. And in this webinar, we will be talking and looking at several advanced options that may come in handy. So we're going to look at models, we're going to look at text to image, we're going to look at tagging, we're going to look at P2PALA, which is a structural analysis, and we're going to look at the creation of tables and what the future will bring for that part. Obviously, at the end, there will be plenty of time to ask questions as well. We will also be able to ask questions between every session. At the end, I will stop the recording so you can talk free, and I will unmute you, and you will be able to ask questions freely and explain what you have in mind to see those questions answered. So we're going to start with models, and I want to talk to you about how to judge the quality of a model, how to compare the quality of models for your documents in specific, and how do you pick a model which you want to work with. So we start with judging the quality of a model, and we will be looking at several different options. So we will be first looking at reading the graph, the tool compare text versions, and also compare samples. So when you are reading the graph, when you open the, when you go to the Transkribus tool, and you click on the models, you always have a graph here. Here you have the German currents, for instance. You have the Danish text from 1870 to 1950, and all of them have a graph. And how do you read these properly? So a good model always needs at least 1,000 lines. These can contain between, well, 7 to 15 words, and most of the time you use about 90% for training, and 10% is used to validate. Why 90% for training? Well, that's to get a computer to understand how the handwriting matches the your transcription, and the 10% is used to check whether the model the computer has created really functions. And again, there it checks the new created text with the transcription to come up with a number how well it performs. So the validation set tells you how well does a computer perform on unseen text, text that it didn't use within the training. What is also very useful, and here we go back to the model. If I look at, for instance, the iceberg model here, you see it has lots and lots of words, it has lots and lots of lines. And you also have here the last button is show character set. And here you see all characters that are included within the model. So you can check whether actually all characters are included. So if you are going to use a model that is already available, please check whether all characters that you find necessary are available. So, or when you're creating your own model, it's useful to check this because maybe your text didn't contain any numbers in the first couple of pages, and you might need to train these in addition to the original model. So you may need to retrain a second model. When we go to this, when we have such a model, it's important to look at the different lines. Ideally, the blue line, the training line, and the red line are very close, in close proximity to each other. If not, you may need to add additional training. So here you see that these lines are coming closer to each other, and then, well, then you know that a model is quite useful. I'm going to show you some examples here, as this reading of graphs may be a bit of a challenge. Here you see a model which has the blue line. The first one, the blue line is very well going down to the x, but what you also see is that the red one doesn't lower anymore. So what does this mean? It means that the computer is being trained very well on the pages that are given, but there is not enough material or not enough information for the computer to perform well on the validation set. So the unseen pages are not really being interpreted correctly. So what this one needs is more training and maybe a second check on whether the validation set is really representative. Here you have a Hindi model, and here you see that the two lines are becoming very close to each other. They are in very close proximity to each other. So that's a very good model, and it's that's the one you like to see. Here's another one, and well, what you may already see is that I use way too few lines to train on, and it basically bounces up and down. It doesn't know what to do, and it doesn't seem to know where it should get its information from. So I needed to train a lot of material extra, and the second one you see here is the result I got when I provided a lot of data more for the training and the validation set, and it actually gets very close to each other. So preferably these percentages do not differ too much, and if they do differ, then please check whether you need more training or whether your validation set is representative for the material you provided the training on. What also might be interesting to be aware of is that when you create your model, you have the option, and I'm going to briefly show you. When you train your model, there's also this, and we looked at it the last time we did this webinar, you also have the option of clicking on the training model, HDR model data, and you can use a training set and a validation set. If you want to compare your models to one another, then please reuse the validation set. You can then just click on the validation set and it appears in the validation field, and you use the exact same validation set. So that will offer you the possibility of comparing your models to one another. Obviously, you can add a lot more to the training set, but try to compare your models and see whether that helps you with understanding what went possibly wrong with your first attempt. But always check whether you had enough words or enough lines as well. So, how to compare the quality of the model to your documents. Obviously, you're very keen on using a model that is already publicly available because it could save you a lot of time. But how do you know whether that model is useful? I can't use a model from a Hindi text to my Dutch sources. but can I use a Dutch model that was created by a colleague and apply that to my sources? Will it work well enough? Well, that depends on several issues. One of the things that obviously that it needs to work needs to be about more or less the same period in time. Geographic location can be an issue, but definitely the type of sources you're working with could be of influence as well. So if you're working with diaries, the text that is being written down, or was written down, I should say, is of a different nature than when you're working on dissertations in the exact same time. So formal language, informal language, that may be of influence as well. So keep that in mind, that you do need to check whether it will work or not. So one of the options you can use to see whether a model works for your text is the compare function. And what you do is you first create a ground truth for one page or a few pages. And then you run a model on that exact same page. And then you click on compare. And what happens is that here you see the reference, the corrected text, so your text, or you could actually run the model first and then correct it, but you want to know what the score is. So the hypothesis, the HTR text, so the model in my case, which is here a Dutch Gothic, you put them in the right fields, and then you hit compare, and then it will provide you with a comparison of these two model, or these two phases of the text, so the model and the ground truth. And here we're gonna do that in a moment. I have a document here which is handwritten text from the province of Gelderland, and I'm going to go to page 27. See, I have put these all in ground truth mode. And what I now want is to compare this ground truth to, yes, there we go. I want to compare the ground truth to the original model that I used, which I can find over here, which is the SITLab, which is the tool they use, SITLab HDR, this model. And I'm gonna click on it. And now I'm gonna compare these two. This is per page. So I'm gonna compare the model and the ground truth for one page. And you can do that for several. Here you see that my character error rate is 5.7 and my word error rate is 3.28. What does a word error rate mean? We haven't dealt with that yet. A word error rate means how many words did the computer need to correct. So if it only needs to correct one character in a word, it measures that the entire word was wrong. So if you had a capitalized character to begin with, and the model didn't write down the capitalized character, then the whole word is being seen as wrong. So your character error rate is probably what you're looking for, because, well, one character or capitalization or a comma aren't necessarily a bad thing if they go wrong. So please keep an eye out that the character error rate tells you more about the individual characters, and the word error rate always will tell you how many words in total went wrong. So here you have the percentages as well, and how many words were accurate and how many characters were accurate. So it was 91% accuracy on the model. So that means in my case that I should probably enhance this basic model, which I got from a colleague, to a more specific model that should be applied to my own text. So there you can compare the individual the individual pages with the ground truth and a model. So you can see how well it performs. So don't run a model over your entire text if you aren't sure whether it will function properly, because that's a waste of time and energy. So here you have again the word error rate and the character error rate. It doesn't show you which words were changed. So what you also have is the advanced compare, which is the second tab in the compare field. Here you can select whether you want case sensitive or case insensitive, and you can also select how many pages. So you will get a sort of graph over the whole document, how much character error rates and word error rates it's performed per page. That might be nice to do for bulky stuff, but it might be more interesting to see what goes wrong. And this might also be of interest if you are working with a group of people who are doing transcriptions for you and you want to give them feedback. So first you have an HTR version of the text and you have someone correct it. You go back to the in progress version, for example, and then you hit the compare text versions. You will be able to see what has changed, and you can judge for yourself whether you find these changes problematic or not. Or maybe you discover that the model doesn't function at all. So I'm gonna show you. Here you see a comparison from the text. What is green has been corrected in the latest version, and what is red was the original version that I have decided to compare with. So in my case, with my page 27, I can now, I go back to another version. So this field opens. I go to a way earlier version. The latest version doesn't get lost, it's still up here, but I go to the in progress version and I hit compare text versions. Here I can see that there were actually minor changes. So here the first character was wrong. Instead of hondgewas, it was bondgewas. And here the actual change was that it had a colon behind it, and here it hadn't. So those aren't really big changes. Here you see a hyphen, which isn't available here. So these changes aren't really that shocking, but at least it shows me that what changes were made if you compare it to the original model. And this can help to give feedback to a transcriber if you compare the version of the transcriber to your final remarks. So if you have to look up certain words or do the final check, you can then send such a report to this person, and he or she may be able to learn from certain errors that are frequently made. So that's the compare text version button over here. And then you have the compare samples button. Samples are very useful if you want to have a quick view of the sources. So you will get basically snippets of the text, and you don't have to scroll through all the pages that are provided in the test and validation set. So it might be interesting to put that on your website or store that somewhere so that you can share that with people who are interested in your source material, but also want to know whether they can use your model. That's also a very useful way of being able to show people what kind of sources you have been working with when your sources are under copyright because of a source publication, or because maybe a museum doesn't allow you to put your source material online because they are working on something with them. And it is also probably a very quick way of checking whether a model works, because you can write down transcriptions underneath this very quickly. What is it? Well, if you hit compare samples, you get this this field, and you can select basically what you want to what you want to use, and you can give the description. You can fill out the number of lines. And what you will get is, in this case, 424 of these kind of snippets, which is randomly selected from various sources. So there's no way of detecting where it originally came from, but you do have an idea of what the text looks. And as you can see here, you have one line, which is this line, and you could transcribe that, or you could run a model over that and then compare whether that works. But visually, you can already do a check whether this kind of print text is similar to the sort of printed text you are working with. If you're working with Gothic and this is what you see, then you're definitely sure that the model that was generated using these sources is not useful for your type of sources. You can still try, but at least visually you can already see that it's not even close. So as a rule of thumb, how to pick a model? Well, I would say check whether it's more or less the same language. It can be the same language family, so I could basically use a German model as a booster, so as a base model, but it wouldn't work on transcribing my own text because of the probabilities and the learning in which order certain characters are. So a French model definitely doesn't work, but German may help a little bit. It would be nice if it's from the same period in time. So a model from the 18th century likely works less well on a 17th century text than when I would use a model from the 17th century, but maybe it comes from a different geographical area within the same country. But keep that in mind. Please test it first on a page. Is the result pleasing? Then do go ahead. But don't run the model over like 500 pages to only figure out that it doesn't work, because it's a waste of server time, but it's also a waste of your own time, because you could have selected another model. And if you run too many models at the same time, or run models over multiple documents, you will be in a waiting. You will be waiting in queue, and well, that's a waste of time. So help yourself and help others not to queue up valuable space while figuring out which model works. Then I always get the question whether I prefer generic or specific models. Well, that depends on your needs. If you want to have a model that works perfectly for your text, then you will need to work with a specific text, with a specific model. But because a specific model requires you to train a lot of pages, to fine-tune pages, it costs you much more time. So a generic model may be much quicker. And if it's only to basically search for certain words, then you can just use a generic model. But if you want to have a digital edition or publish it somewhere and it really needs to be perfect, then go for a specific model. But you can still use a generic model as a base model for training the training your own set, because as I explained the other time, when you use a base model, you only need to train something between 30 and 50 pages. And if you need to start from scratch, you will need at least 75 pages, plus a bit extra if you have multiple hands. There's one question whether what's ground truth? Well, ground truth is basically the corrected text. So if you have scrutinized text, then you may be able to call that a ground truth. And that is, well, most people, some people would say that you would have a text that is 100% perfect. Well, 99% or 89% is also very good, and you may call that ground truth. And when you are working on your text, sorry, I'll need to put this one right again. We go back to the ground truth. You will put the corrected text in ground truth mode, and those texts you can use for your model, because it will make your model more sound. Can you see in which character a model goes wrong most of the time? Then you have a bit of orientation in assembling your training data. Yes, you can. If you, what I just, I'm just briefly going back to the previous version of this same text. So I go to the previous versions button, which is next to ground truth. I select the original model, and when I then compare text versions, so I want to see visually what goes wrong when the text is being corrected, then I can see that in this case the hyphens at the end go wrong. Well, a comma doesn't, in this case there was a comma missing, so maybe I need to check whether the model ends or that my text regions are really going to the end of the line. That's one of the things I can detect from here, because here is a hyphen missing as well. And in this case, we also see here is the word elected, and it doesn't seem to know that a word reflected in this case. So it may well be that by looking at these text comparison, that you detect that a certain character is more often wrong. One of the characters I know goes very often wrong with this specific model is that it doesn't know the Q, because the Q is quite a rare symbol at the time in the Dutch language. But we do have kwartier or quarters, which is part of the province of Gelderland. So in this case, I needed to train the Q a lot, and that's something that I can see over here, that it has needed corrections on the Q. So if you compare a couple of pages, you will be able to see which characters go wrong and which ones need more training. And by doing that comparison already and having created the ground truth, you may already have sufficient additional information. So are there any more questions so far? No? Perfect. Then we go to text to image. So text to image is a very neat tool. It's also a little bit challenging, but since you're here in the advanced workshop, you're probably up for a bit challenge. But it's also very useful. This slide I borrowed from the READ team, and here on the left side you see that normally you have a training set, you create a ground truth, you have a bit of training, and then you have your automatic text recognition model. What you can do with text to image is that you create the option of the computer connecting an original transcript to a picture. And with that, you may already have a lot of ground truth. So I know, for instance, that a lot of archives have very enthusiastic groups of volunteers doing transcriptions, and they may have started with that in the 50s or 60s or whenever, and these are already available. Well, if you're a little bit later on in the 90s, people would actually already put these in Word, and you have transcriptions. And Text to image allows you to connect the original image, so the photo of the archival source, to the transcription, and with probably less pain than having to transcribe the whole thing anew. So where do you go? I will show you several methods. First, we have to go to the tools again. And yeah, let's first explain when you use it. If you have transcriptions already available, but these aren't matched to the images yet. You can also use it to ask one of your colleagues who may be working on the same in the same field, or your supervisor who is working in the same field but hasn't gotten any clue of digital humanities. And it would help you enormously if you crack the code of that specific handwriting of that specific author. So this professor may have used the letters from this and this year to this and this year, and you are working on an entirely different period, but still the same author. Then it would be useful if you already used the data that this person created, so those transcriptions with those original sources, because you can create a model that you can use for the other sources. And then this is a very effective method. Mind you, when we write on our notebooks or in our Word files or text files or whatever, you might have the tendency to put question marks in there, or well, maybe even put in the indications of where you edit text, or where you are uncertain of what the word says. These kind of issues you need to remove, because you can't tell the computer that a certain blob is a question mark, or you can't tell the computer that these characters are question mark, question mark, question mark, because the next time the computer comes across these characters, it will put in question marks, whereas you may already recognize that word in another case. So be specific. As I explained in the first webinar, Roman numericals, so the X is always written down as an X and not as a 10, because if you would come across the word sex, it would end up with being SA10, which is not a word. So the computer gets confused, because it only learns by what you tell it a character can be. So the question mark is a problem, because it's not a word, and the computer will learn that a certain blob or a certain character would be transcribed with a question mark, and that would confuse reading the text. So you better leave it out. You better leave blanks instead of question marks in that case, because the computer reads both back and forth and up and down and in all sorts of directions. So even if you don't know the words in the middle of the sentence, but you don't know the beginning and you do know the end, the computer will be able to match that in his recognition of the word that you transcribe to the beginning and the other word being the end. And even if there's a bit in the middle, it doesn't really care. So there's a first method, and I have sent you a couple of files along with the registration information, and that information contained 3 pictures and it contained 3 text files. Well, one of the things you need is that one of the most important things you need to work with text to image is that you need text files per page. That might be a bit of a shocker for some people who do not know how to program. If you have your Word file or you have your text file, you will need to separate it into individual pages. There are a lot of people who can just program that for you. Please be aware that you need to save your document in a non-Word environment first, so either in text or in LibreOffice, because somehow Word seems to corrupt your file and add some bits in the background which do not help the computer. But you can actually write in a few lines in Python a script that could separate your whole document into individual text files. So if anyone volunteers to create it, let me know. But it's easy, and I have seen someone do that. So you need individual text files per page. Most of the time you give an indication already, as in this is the transcription of page 1, or this is folio or recto verso, or something you indicated in your document, and you can train the computer to separate the files. And again, check whether there are uncertainties, so question marks and these kind of things should be removed unless it's a question mark from a sentence. And then you already perform the layout analysis on the uploaded files, and you go and match these. I will show you in a minute. This is what you see in the in Transkribus. You hit the 3 lines. That's a fold-out menu. You click on document and you go to sync local text files with the document. In the a few versions back, you still needed to upload the text files straight away with the images. That's no longer necessary. So you can pick these up from your desktop or wherever you have stored them. And or if a colleague later on pops up and says, like, I have the transcriptions of this and this file, you can match them to yours. Then there's no problem in having to upload the whole stuff again. So you can still add those. And then here you see the next screen you will get. You have the text files and you have the images. And here you see that these will be matched to each other. And in this case, I use the existing layout analysis because that's something I already performed. And I'm going to show you this version first. I'm going to open a text to image file, which is the same you received. Here, this one is still very full. In case you don't know yet, if you go to layout, you can remove the whole content just with the cross. And I will be briefly deleting all the text from each of the 3 pages, which gives me the opportunity to show you that it can match the text to the 3 pages straight away. And here we didn't have. So here I'm going to draw quickly some text regions. I'm going to save that. In the case of the document that I sent you, which is this document that you are now seeing in your screen, there are a few marginalia available, but those aren't available in the transcription. So in this case, I'm deciding not to put a text field, a text region around the marginalia because I'm not going to use them. But that's a choice. That's the choice I'm making right now. And here we go. I'm gonna save it. And I'm briefly going to find all the baselines. You see one job started. And in the meanwhile, I'm going to sync local text files. And on my desktop, I have a text to image. I have a text box, a folder called text. And that's the folder I'm going to select. And here you find, I'm going to briefly show you how the content looked, because you might want to know. I have text files and I gave them a name according to the page they connect to, which is probably most convenient. Here I can tell you which one needs to be connected to which one. You can double check below. If I think I need to change the order, I could actually do so if I find that necessary, but in this case it matches. And I want to use the existing layout which I created with the layout analysis. And I hit OK, and it will now synchronize all 3 pages. In this case, it won't match the last 2 because I only did the line detection for the first page, but that's not a problem. I needed to match it to the original layout. I need to tick the box, and now it will sync and load for this first specific page. Here you may see something, well, it kicked out the rest of the analysis. I'm not sure what happened. That brings us to the second option. This should work, but something quickly goes wrong in this case, sorry. But there is this text to image button here, and I choose a model. I'll briefly explain this first. So it can match it to the existing layout, which just didn't work for me at this moment, but it should because it did an hour ago. Here you can perform the text to image configuration. You can choose a certain model. In this case, I take the Neo-Latin because that's the model that was based on this text. And I perform a layout analysis because it kicked out the layout analysis. And if you use line breaks, you can delete them if you want, but you don't have to. And the edited status of the document you can change over here, but here it means that it will perform on all the pages that that you haven't used or that are available. You can allow it to ignore text. You can allow it to skip baselines. So it doesn't need to match to every individual line. If you want, you can ignore the reading order because if you have it perform the layout analysis by itself, it may well tell you that here is number 1 and here is number 2. But we logically would see the second part as the marginalia, so we would probably give that a different number. So you can ignore that if you want. And you can also give a bit of a threshold. So in case of doubt, if you want it to be perfectly matched, then you choose 0. If you want it to match, but with a little bit uncertainty, then you can choose the 0.05 and you run. Because what it just did was that it matched the text to the whole page. So the whole page and the whole text were one and the same, but you want to be able to create a model to match it to the individual lines. You can see that it's performing layout analysis on my first page, on page 1 of 1. And remember, this is very useful when you have a lot of bulky text. So if you have like 500 pages of transcription, it might be nice to match this. And depending on how certain you are, you can either have the computer figure this out with the complete layout analysis, or if you want to be able to select certain areas, you can do the layout analysis first. Because we will be seeing that when it performed the layout analysis automatically, it did put lines underneath the marginalia, and since there are no transcriptions of the marginalia, there are going to be some blanks here. So we can see that it's now doing the text to image. It will nearly give a pop-up that it's ready. So we can now see that there are a lot of blanks because we told the program that if it didn't find the correct text, it shouldn't match. So here we see there is no matching text for this bit. And as it also numbered the marginalia, we see empty fields here. But most of the lines have been matched correctly. And that's also because I selected a model that fits well with the with this specific text. But if your model is like 20 to 30% certain, it can still match a lot of the text because it only needs a couple of characters to figure out whether a word or a sentence fits within the certain with a certain line. So this is the method where you have the computer figure out the layout analysis and match the text. And if you don't have a base model yet, which would be fitting for your text, then you do either a couple of pages manually with the first method that you draw the layout analysis first and then have it matched to the specific lines. Or there is a third method, and that I will be showing you in a second. So we have had the layout analysis. We have the match. We did not use the layout analysis because there was no layout analysis available. You match the text to the full page. But because you need to figure out where the lines are, you need to perform the layout analysis. You perform the layout analysis and you also provide a base model. Please ignore text as an option. Skip baselines. If there is no sentence available, then the computer should be free to leave it out. But if you are sure that all the lines are available in the transcription, you can just ignore this as well. If you're not quite sure whether the computer can figure out the reading order, that's fine. And if hyphens have been used, then tick the box, and it will be slower, but it will be more accurate based on your transcription. If you want to have full control over your text and over your transcription, maybe because you are going to create a base model, then create the layout analysis first. And after that, you can check it, whether it has performed correctly, whether you are satisfied with the results. That's always very important, because if you want, if you're striving for perfection, then that's what you need. And as said previously, there is this merge button which appears if you select two lines that you think are should be connected, and then you can actually merge these two lines because sometimes they write at the beginning of a line and at the end, and the computer sees that as two different things, but you want that to be one. Then you can merge these shapes. And do save your layout analysis. And I'm going to show you this. And then the second step is basically to paste your text. Sorry for the typo, which is the Dutch word. And then enter the text in the first line. I'm briefly going to show you. I'm gonna copy text that I had before, and I'm gonna paste that in the first line, which is obviously way too much for the first line, but since I already pasted it here, it automatically puts it down here. And I might need to correct and check because, well, as you can see, there's still text over here and it's missing here. So there is somewhere a line which is wrongly matched, and that's likely over here. If you want to know where you can find these numbers, the line order, reading order of lines can be ticked over here. And that's where when it appears or it disappears. And you can also show reading order per region or word order, these kind of fancy stuff is all over here. And it's sometimes a bit of a challenge to select, but I can see that here, if you do a Control Enter, it moves the whole bit down. And if you happen to be wrong, you can do a delete and it moves back up, but that only works if the line prior to the sentence is empty. So in this case, I still need the enter, and you can do a backspace or whatever. Up here we see an error in the reading order, so I can tell the computer that it shouldn't be 5, but it should be 4, and it can correct that. And I think we may have found our error here. Here the word nose is separated from the rest of the text, so we can merge the two. And now we still need to check whether the word order is correct, but at least we have found our missing or our redundant line. And it's, in this case, it's actually reversed the whole order of the sentence. But here you can still correct these kind of things, and you can change the order of the sentences and well, correct the whole thing so that you have a perfect matching text. As you can see, most of the text is already matched correctly, and here I can adjust these kind of small issues to make the perfect matching of the available transcriptions to the available images. Besides from the minor problematic issue with the first option that you do want to match it to your layout, are there any questions? Yes, this is something you probably need to see a couple of times before getting the hang of it. You have to put all the text in individual text files to do the matching. So you have, and they need to be in TXT. And that's definitely a bit of a challenge, but a Python script can help you a lot with that. So then you resave your Word file into a ODT, so LibreOffice, for instance, and you can actually have the computer do the separation in individual text files for you, which should be rather helpful. But because they are in individual text files, the computer is able to match them to the individual pictures, because otherwise it will need to search through a whole file of maybe hundreds of words, and that will be complicated for the computer to do. So indeed, if a document you are using has 10 pages, then and you have the original transcript available, then the transcript needs to be separated into 10 individual pages that it originally contained, in 10 individual text files. So then I propose that this is something you should try for yourself first. When you first upload the 3 pictures as one file, you probably already know how to do that, which is the upload. and you upload a single document. So please put all 3 pictures in one folder first. You select, you go to your desktop, you select the pages, you tell the computer what the name should be to upload, and it will upload the 3 pages. And please do that to your individual private collection. So you all have your private collection. And after you've uploaded, you can go to the layout analysis menu. You first have to synchronize the local document, and you're gonna find the text file, and you're gonna match it. And you obviously first do the layout analysis and then tick that box. So please do the upload first. I'm gonna perform the layout analysis, and we go step by step through it. So you don't need to do the layout analysis if you just want the computer to do that. It's just a higher accuracy method if you do the layout analysis first. So in this case, I'm doing it because I didn't want the computer to think that the marginalia are relevant, because I have no transcriptions of those available. But if you don't care about that, but you're just out there to get a model, and well, if the matching is done in a good manner, then you can get your model. And even if there are lines empty, that's no problem, because empty lines don't perform data or don't give data to create a model. So it only learns from the lines that are available. Then you can just have the computer do the matching. And here we have the lines available. So if you want, you go to the, this is the one that just happened to fail before. I tell the computer that I want from the folder of text. I select. In this case, I just want to use layout analysis. I want my second page to match this one, which is in this case also called page 1, but has the name 002. And now it will match. Hopefully the computer has no hiccups this time. And here we go. We see that there was one minor issue. That's because of a line break that was available in the transcription. I pressed delete, or in this case I pressed backspace, and it's now matches the lines with the document. So here we have that available. So this time it worked. So please give it a try, and you decide for yourself whether you want to practice with layout analysis performed by yourself, or that you have the computer perform that for you. So if you need to do the manual layout analysis, then you go to the text region, which is the top button with the TR, and you could draw baselines, but you could also go to tools and then unselect find text regions and run, and it would find you the baselines. If you find it difficult to phrase a question, you can also phrase it in English or German or Dutch if you want. French would work probably as well, but other languages I can't answer. Yes, when you, I'm going to briefly show you when you want to match without the layout analysis done by you first. Then it first matches it to the whole page. I'm going to show again. And here I need to select that I want to match it to this page, then it matches it to the entire page. So you will need to go, first let's match, because I'm too fast otherwise for myself. Here it has matched. Oh, I need to go to the second page again. I have just had it match. And what you will see is that it figured out that there are several lines which are available in the original transcription that I just uploaded. But as you can see, it selects the entire page. So when you want to have the computer perform the layout analysis, you have to do a second step, which is that you go to the text to image button. You select, in this case, that I want to match it to the current page. You could also do that for the entire document. You select the base model. In this case, for the document I sent you, you can select the public model Neo-Latin. You click that you want to perform layout analysis. Well, in this case, you don't have to click edited status. I have selected the thresholds that it can do whatever it pleases, but it needs to match as much as possible. So it doesn't need to be perfect, but at least I will try. Allow ignoring text. So if it doesn't find the text in the transcription, then it can leave it blank. And I also allow it to ignore baselines. And now I hit run. So now it first creates a layout analysis, and then it matches the text to these individual lines. So if your page turns a bit bluish when you click on your individual lines, you still need to perform a layout analysis combined with text to image, which you find in the tools tab in the other tools text to image. So indeed, otherwise it's one big giant line. And mind you, this text to image can save you a lot of time. If you have a colleague who figured out how to transcribe the hand of author X, and you are working with the same author X, but you're working with different documents, then it might be convenient to sit down and do this for a day or two and be able to create a model and convert the next 1,000 pages of that author X of your own text, and not having to figure out every little detail of that author's hand. You see it created the layout analysis, and you see that it matches now the lines to the individual lines on the photo. So it's no longer one bluish page, but now it has matched it to the individual. The only way to have the computer ignore the marginalia is either by now deleting them. Since they are empty, that's not a real problem. I can actually delete the entire section. Or do the layout analysis and draw the text regions by yourself. But you can't tell the computer that it doesn't perform a layout analysis on the specific marginalia. When you choose a text-to-image base model, you choose a model that is closest to the text. So in this case, there is this Neo-Latin model available, which I actually created based on these texts for a colleague of mine. But if you happen to have a Danish text and you want to use a text-to-image, then select a Danish model, which may be available because there are several. If you have a German text, then you pick something Germanish close to it, but please have a base model that is less than 30% character error rate, because that helps. And you can also create your own base model first based on the first 30 pages or something, which might be more more work, but if it matches your text more correctly, then you save a lot of time again. if someone has a publication of a certain source, you can well, make a PDF of it, copy the text, put it in Word or in a text file first, and match it to the originals, because your the source, the scholarly edition, could already help you with getting an easy model for the sources you are working with. So try to find ways to get yourself a model and make life easier. So first, synchronize the text files to the images. And if you want to have the computer perform the layout analysis, you then click the text to image button in the tools tab and have the computer perform it based on the base model. So the base model is very important because it helps the computer understand how characters look like and how it should match the text to certain characters that are on the page. So we're now going to talk tags. I want to talk to you about adding metadata, also adding how to tag words. Probably most familiar are the named entity recognition, which is something you do manually, and also how to do structure analysis. And structure analysis is already a little bit information which we will use for P2Pala. So how to add document metadata. When you are in the program, you go to the tab field, and there you click on metadata. And metadata has 4 different subtabs. And the first one is document. And here you have the title, you have with the authority, external ID. You can basically fill this all out as additional information. And what can also be very useful is that you insert the editorial declaration. And what does that mean? Well, you basically tell people who might be using the document as well what kind of characters are available in your text and what you have done. So if you use a V instead of a U, or if there is a long S, or there are geonames tagged, you can actually mention that and you can select it, and these selected features will then be shown. And these are supposed to be added to the front page if you are exporting your files. That's not always the case yet, but if it doesn't, then send in a bug request or a bug or a feature request that they will add it, because it might be convenient if you can show the choices you've made. So in the metadata declaration, editorial declaration, you can add these kind of information. You can add whatever kind of extra information here as well. You can choose whether it's printed, what type of text it is. So basically, this is the information that you would be using to retrace your own steps, or when you share a file with someone else, they can quickly read through and find this information. So that's probably self-explanatory. How to do word tagging? Well, there are several options, and the first option is when you are in your transcription field, you do a right click. You have this fold-out menu which shows you all tags, and then you have several to choose from. So you can also indicate that a word was unclear. That's more regarding the transcription, but you can also say that something was an organization or a date or an abbreviation or whatever. You can also do that in metadata, and then in the subfield of textual. You can then add the properties and define these as well. You can add whatever you like, and you can specify them, and this can help you basically do the same thing. I do need to stress that this information does not go into any kind of model. So you can export it when you export your file to a XML export, for instance, then this information is inside of that XML file. But if you are hoping that by tagging the city of Timbuktu, it will recognize that everywhere in your document, then I'm sorry, it doesn't. Maybe in the far future that will be the case, but yeah, for now it doesn't. If you would like to be, if you would like that to be the case, then well, since I'm not affiliated to Transkribus, I can do whatever I like. I would suggest that you have a look at Recognito, which is from Pelagio, and in that program you can actually tag like the city of Timbuktu, and it will show you the georeferences, and you can say like, okay, this is the same city I mean, and it will tell you like in your file, which you can actually upload as an XML. I have found like 200 references to Timbuktu. Do you want me to tag them all? And then you can select that, and you can do that with several of these kind of references. But within Transkribus, it's all manual, and it doesn't get fixated in a model to automatically detect it throughout the document. This is also possible within the web version, and I somehow seem to be missing that slide, but maybe I'll enter it later on. But there's also a field where you can annotate, and you can there select unclear, but you can also select whether something is a geographical reference or a person or a date. There are not that many options in the web version, but just a few that are most common. So how do you do structured tagging? Again, we go to metadata, and we go to structured tags, which is the second sub tab. And you can see here a couple of names. And if you have a text region, you can select it and then click on which one is applicable, and it gets that name. Why is that useful? Well, as a colleague of mine phrased it at a conference, the structure in a text wasn't there for nothing. So if it's a book, then the author or the printer thought of why a certain structure needed to be there. And it can also be very useful for your XML output. If you're just using a Word document or a TXT file or a PDF, then it's not so relevant, but it's useful for your XML output because you could actually search for all titles or all paragraphs and leaving out the titles. So you can query for specific parts of your text. And well, what we will be seeing in the next session, you can use this also to train a structure recognition. So I will be showing you this in a moment. So we go back to our Latin example. Here we go to metadata, we go to structural, and this whole section, the text region, we can either click here on structure and select it, or I select it as such, and I call this the paragraph. And you see it gets the light blue coloring. And if I want, I can then draw a box around here. And I have to go back to my arrow, and I can call that a marginalia, which is somewhere down here. Yes, I can call it a marginalia. And you can see that now the structure tag says that it's a paragraph. and the other one says it's a marginalia. And here we actually have a page number, which I can give another one. So why do you do this? Well, first of all, you only do this when your document is still empty. If you do, well, you can actually do this when there's text, but not if you want to perform a layout analysis through P2Pala. Then the text still needs to be empty. There is no text at the lines filled out yet. So then you do the complete analysis first. So if you want to publish it online, have it being queryable, then you do this very precisely. You call things paragraphs, you call things page numbers, and whatever. So that's basically the purpose of this, to be able to find these structures back. And obviously this is also now available in the XML, and you would be able to find that certain regions are now renamed. And see if I can. See if I can find it. Well, you would be able to find it here in the XML viewer, so that you can then see that something is a page number or marginalia or whatever. So that's somewhere within this information. Let's see. This one goes away again. So you do first, preferably first structure text and then baselines, because it's also easier to see if all goes well. Oh, and here in the web interface, you don't do the structure tagging, but this is what I wanted to show you with the annotation for the named entity recognition. So that's available in the web interface as well. Are there any questions on how to do named entity recognition by hand, or questions regarding the structural tagging by hand? And you can create your own tags if you don't like the English names and you want to have it in Turkish or in Russian or whatever. You can actually customize these and add your own and change whatever you need. You can also change the color if that's working better for you. So if you want to be precise, indeed, first text structures, then perform layout analysis for the baselines. So the text regions are actually the ones you give the structural text to. In the example we had, this base part was the text region I first drew, and that is what I called paragraph. Oh, then we go to P2Pala, which is basically oh, there's one more question which is relevant to what is being trained within the models. I just mentioned that the named entities aren't being incorporated into a model. The same thing goes for superscript, subscript, strike-throughs. Those aren't being remembered within a model. So HDR models do not remember things such as superscript and subscript because that's too much info for the computer to remember. It can only remember 100 characters that are written in various ways. So it needs to figure out if where all the dots and the pixels are. And for the computer, it's too difficult to make a distinction between italics, superscript, subscript. So it will always transcribe that as normal script if you run an HDR model. So here we go for P2Pala, which is a structure model for automatic structure application or analysis. Well, this one I just showed you, and I have here information that there's a page number, which is not actually true because it's a column, but that was too much info. And here we have a paragraph, we have a heading, and we have a header, and these have all been indicated. And with P2Pala, when you want to use it, you first have to drop an email to the Read Co-op team to ask whether they can provide you access with it, but I can already show you, and then you know what you can ask for. P2Pala is a tool that will create structure models, so layout models, which is totally different than HDR models. HDR models are the models that focus on the content of the text. So how is it something written and how can I automatically transcribe the rest of the text? And that's HDR. And a layout or structure model focuses on what elements are on the page. Is there a title? Is there a paragraph? Is there a marginalia? Whatever. So it focuses on the structure. And to work with it, you need about 50 pages to 100 pages being trained manually. So that is, you can still use the automatic detection, but you will need to name every little bit and piece, as in being a paragraph, being a title, etc. If you do baselines, then you need to check these too, and you will need more pages to train. So this is still a bit of an alpha version. It's still being developed, so in a few months' time, it's likely that you will need less pages or that you will be able to tag more. So at this point in time, you can only work with 5 tags. That's not to say that you can't tag more, but the model only works on 5 tags. So be very careful what you wish for, because page numbers are on every page, and you kind of need to find a balance between these kind of things. So if it's important for you that you have the paragraphs on the left and the paragraphs on the right and the titles and maybe the marginalia, then that's what you train, because you can probably derive the page numbers based on either the file name or these kind of issues that are automatically contained within the document. So you might not want to waste your time in tagging these, or at least you might not want to use that within within creating the model. The example I just showed you here was a printed text, and because the computer works a bit with coordinates, but also with pixels to figure this out, it was easier for the computer to figure out that this was a paragraph left or a heading left, and that this is a paragraph on the right side. So you might need to think about, are certain issues specific to the left side or the right side of my page, and then be as specific as possible to give that a specific name as where to find it, so that you help the computer that the structure tag paragraph left is always somewhere on the left side. But if you have like 6 times paragraph left and you have 600 times page numbers, then the computer is a bit ticked off, and it will not know, well, it will be a bit confused if it comes across something and it's not sure whether it's paragraph left, then it will automatically choose page number, because it knows, well, that's the mostly available feature, so it will choose for that option. So try to strike a bit of balance. So when you go to Pitupala, you can train your own model. So that's the button you would be requesting. You could also select a model that is already available, but if you haven't trained it for your specific type of text, I would highly recommend not trying to use any kind of model that is sort of publicly available, because it's likely not to work for your text. So you give it a name, you give it a potential description. The number of epochs is how many times it will train upon the whole set that you provide. And here you have structures, and you can click on the plus, and you can randomly select like 5 of them, or maybe 6 if you're lucky, that you want it to be trained. And you can actually merge structures. So if you have a header and a page number, you could actually merge these two, because these are on the same sort of coordinates. They are always on the top of the page, so you might be able to merge them. You will be selecting the edit status, because you have been putting a lot of work into this, and you don't want the computer to learn from the pages that you did not train. And you select the document that you wanted to perform on. Have it do this randomly. You could actually do this to 80, 10, and 10, but indeed it can do a analysis, or it can do a random selection, and then you know how well your model will perform. Well, I'm going to show you. I have a document over here. Actually, I have several here. And it's just opening up. It's a very large file, as you can see. Here in the overview, I can see which pages I've worked on because of the status. And here, if I go to structural metadata, we can see that I gave it several names. Well, in this case, this is not the best of examples, obviously, because these were all called paragraph. But here you can see I have a header, I have a place date, and I have the paragraph. If you give it names, if you choose names yourself, make sure you don't capitalize, which I did here, is not very useful. Don't capitalize, only use small characters, and don't put spaces in there. Now I'm going to go to Pitupala, and I want to train a model, and I'm just briefly gonna call it XXX. I'm gonna select documents. I'm here selecting 3 documents, and what's very convenient is that I can analyze. I still need to tell that I only want the ground truth and skip pages with missing structure. And here I now have the computer analyze the structure types that are available. So it will go through all 3 documents, figuring out whether I have page numbers, whether I have headers, whether I have paragraphs, marginalia, etc. And it will figure out which structures are mostly available. And as you can see, here it says paragraph left. Well, preferably I would have around 40 to 50 of each. That would be helpful. If one is very much absent, such as bookbinding here, then that's not a very useful one to have the computer search for, because it won't be able to find it. So now I could actually click here on structures, and I could say, well, there's a paragraph, well, let's select that one. There is a page number. Let's select that one. And if I have about 5 of them, I could actually select the merge two structures. And then I click on train a model. And well, it takes probably 2 to 3 hours. And then you have a structure analysis model, which you can then run over the rest of your document. So why would you do this? If you have like a governmental document or a folder which always contains the same kind of layout, then this is very useful to use, because you will be able to search through the layout and this and use the analysis of the structure to quickly find your information. If you don't care and you only want to search the text for words, then maybe give it a second thought to whether your colleagues might be interested in the layout. But if that's still not the case, then don't waste your time and energy on this, but just get transcribing and HDRing the text. But if layout is an important part of your research, then this P2Pala page-to-page layout analysis can be of help to, well, to basically create a way through the analysis of the text. Are there any questions about this? There is a data set of 1, 2, and 3 columns. You would indeed have to make a bit of a mix on that, but you may not need 50 pages each. I would try like 30, 40 for each. And you can then also give it a try, and if the layout analysis doesn't perform well, try again. You could do this P2Pala with baselines as well, but with baselines it's less accurate, is my experience. But if you correct the baselines, that could also help. The order of structures does matter in that sense that if well, it both uses how it looks and a bit of the coordinates where it's located on the page. So if you have a title that can be everywhere on the page, then it's convenient if you have examples that it is at various spots at the page. So it learns that it is a certain size and that it can be basically everywhere. But if a page number is always on the left-hand side top, then that's something the computer also learns. So it both learns from location and it learns from position. Position and pixels, so how the size of it. Are there more questions about this? If there are many structures on the page and you're only interested in paragraphs and headers, that's totally fine that you don't tag all the other elements. You could consider tagging it for being able to add that in the near future. I'm still hoping that P2Pala becomes text enrichment rather than the basis for the whole, before you do the HDR analysis. So if you already did the HDR analysis and then you do P2Pala, then your pages turn out empty again and you still need to do the HDR again. So you can indeed, and you can indeed train P2Pala with baselines as well. So it's more efficient if you train only the sets that you are really keen on using. But if you know that a colleague might be needing the rest, well, you might be considerate about that as well. If you have columns, you could, you have a capitalized character at the start, you could actually draw the whole box of the text region around both text plus the capitalized, the capital at the beginning, and have that as being one if you prefer. If you prefer the capitalized, the capital as being a unique thing, then you could draw a separate box around that and give that a specific name. So that's depending on your choice. Any more questions on P2Pala? One thing I find a little bit frustrating, but I know that it's going to change in the future, but not sure when, is that if you would like to use P2Pala to train tables, because you draw all the individual cells, then P2Pala won't create that model to apply that to the rest of your set of tables yet. But that will change in the future. So, but that bridges us, brings us a little bridge to the next topic, which is tables, and what tables will bring. And about 3/4 of a year ago, well, yeah, about 3/4 of a year ago, I was put in touch with the NaverLABS, which is a group of, or an organization, a company who works with artificial intelligence. And they are working with Transkribus, and Hervé Desjean and Jean-Luc Meunier are very active there. And you see here a couple of links of information they have put online regarding what they do with tables. So their main focus is table recognition, and or more specifically, the content of what is in those tables. Their table understanding tool expects to have a new release in June, and it will be implemented in Transkribus, and it's planned for this year, but obviously due to these very strange times, we're not sure when or what will happen, but it will at some point be included. And I've heard rumors that a standalone version of an open source version of their tool can be expected too. So keep an eye out for these guys, because they're doing a really great job. And you will see why I am saying that. You know, you can tag tables, and well, if you have names, these are all in columns. And the tricky bit is that the lines are not always as readable as or as visible as you would like. Sometimes the lines are even absent, and sometimes authors are not very precise, and they have written in the various boxes, which is well, probably very annoying for those working with tables. And what NaverLABS does is they are working with the original images and the correspondent extracted table. So here you see an example from Passau. They have been the group from Passau has been focusing on the tables for a long time, and this data is now being used by the NaverLABS people to convert the meaning of the tables into what you and I would understand as a table, and have the computer understand that in the same way. So here you see, and this comes from their blog post, that the original text and the transcription are now being matched. And one of their examples based upon these sources from Passau is that certain professions are more or less available in these areas, or more professed. by people. They do disclaim that they are not historians. This is basically what they just got out of the data, so someone should check it. But this is what the computer understood from checking these sources. So what do they do? They have the ground truth. Oh, sorry. Whoa. They have the ground truth. They do the line detection. So where are the lines? Then they make a table understanding out of that. And sorry, this is the slides I got from them. And then you get an extraction of the information. So you have the OCR, you have the position, it figures out where it is positioned, it comes up with a layout structure, it puts it in a database, and then you can analyze the whole thing. So you have nodes, you have nodes, it figures out a relation, it figures out the information on the page, and then it reconstructs the document based on this information. So here you have it in practice. You have the different cells with information, and it then understands what is in the various rows, and it understands what it has in the various cells. And based on 3 hours of training, it had a recognition of about 95 to 99% understanding of what was in the different cells. And here again, when they only looked at the rows, in 3 hours time, they had nearly 1,000 pages it was trained on, and the computer could then understand what was in these different fields. And again, this is all done by artificial intelligence. And based on this information, these tables, you can then plot it on a map, and you can go back to the original files and see what information these files contained. So it has back and forth references. You can actually check whether it was transcribed correctly. You can search through. Another example. So this is also based on those tables, and they have queried them, and these queries are now being put on the map. You can see where scarlet fever was more problematic than at other spots. So if you're working with tables, the good news is this is being implemented in Transkribus. The bad news is we don't know when. But it should give you the awareness that it's not that your efforts are not for nothing if you are putting all these regions around the individual cells, and you could actually contact the NaverLAB people and see when they might expect a release, or ask the people from the re-team and see when these things may be implemented. So this is probably something of great interest to the social historians or to the economic historians, but it shows you also that understanding the tables and being very precise with that could be of help for future visualizations. Are there any questions regarding the table bit? And I hope I can answer it, because this is still a little bit of futuristic features. Yes, you could basically use this for any kind of lists that you might come across in the archives. The NaverLAB people work both on a structural and textual level, so they can yeah, they both need it, because the artificial intelligence needs to understand both the position and the words to be able to to come up with sense. It needs to make sense of the information, so it needs both info. More questions regarding the tables? Yes, the table understanding is definitely used to define the data, because it's kind of makes sense of what is in the lines, but also what's in the rows, and that combination of information is used to make sense of the whole. And with that, it can point you to names, it can point you to dates, it can point you to selling places of slaves, or names of slaves or owners, or you can basically make sense of tables in a way that we humans do. Although we don't really seem to know how artificial intelligence does these kind of things, but the way it looks to me, at least, is a way I would understand tables, and that the computer is able to figure out in 3 hours, based on 1,000 pages of text, how tables should work and what's defined in them, is something that I find very promising. More questions so far? I already showed you this this slide in the previous webinar. This contains some links to well, other information you could consult. The Scantent, there's a very active Facebook group for Transkribus users. It's not run by Transkribus, but by the users. There are a couple of people from the READ team in there who also answer questions, but mainly users will point out how to solve things.